Okay. We talked about my glasses, right? I got new glasses. Did we talk about that? Yeah. They're progressive. What is it?
You can set them up and do exercise with them.
And then play baseball.
Yeah.
Yes, I can play the outfield again, exactly. Okay, I'm going to read a problem to you, all right, and then we're going to work it out on the board. We're probably going to do one or two problems, and then we'll have the presentation on magnetism. Okay, now, it says, may I read it aloud? Is that okay?
What page?
We're on page 4, 5, 9. Okay, you ready? It says a balloon. Okay, let me just yell at a couple of students and watch how I do this. You ready? Thank you. Okay. A balloon inflated at room temperature, 24 degrees Celsius. So that's a temperature. So we're going to put the word T down and we're going to say 24 degrees Celsius. I want somebody out there automatically converting it to Kelvin for me. Okay, now, it says it has a volume of 4 liters. So there's a balloon at room temperature, and we're saying room temperature is 24 degrees Celsius, and it has a volume of 4 liters. So we're going to use the word V for volume and say it's 4 liters. Okay? The balloon is then heated to 58 degrees Celsius. So now we have 2 temperatures, right? How would we indicate that these are initial conditions? What would we use to do that?
T1, V1.
T1, V1, exactly. Very good. Excellent. So now we have a T2, and that's going to be 58 degrees Celsius. Anybody do a conversion to, yes, what do you got?
There, it's 297
Kelvin.
Yeah. And 329.
Good, excellent. And it says, what is the new volume if the pressure remains constant? So P is constant.
It's actually 331 Kelvin.
331?
Yeah.
Down there, yeah.
Yeah.
Nice recovery, Pablo, thank you.
All right.
That's okay. All right, so let me read the problem again all the way through without stopping. A balloon inflated in a room, 24 degrees, has a volume of 4 liters. The balloon is then heated to 58 degrees. What is the new volume if the pressure remains constant? What is the new volume if the pressure remains constant? So V2. Okay? Yes? Now we know the equation. This is going to be Charles's law. We know the equation for Charles' law. It's V1 T1 equals V2 T2. Right? So plug in. Plug in. Okay? Let me see if that's coming up on the screen. And it is. We've got plenty of room over here. So let's rewrite the equation over here. V1 T1 equals V2 T2. V1 is going to be 4. It's in liters, Kelvin, so we're cool, right? With the unit labels, we can just plug numbers in, yes? So this is going to be 4 over 297 equals V2 is what we're looking for, and 331, correct? So cross multiply, 4 times 331 divided by 297 is what?
4.45.
4.45. So V2 equals 4.45 liters. And that should make sense because I'm increasing the temperature, I should increase the volume, correct? Make sense? All right, we're going to do one more problem, and we're going to use, it's actually a problem from the end of the chapter. Okay, and this is the problem. Here's the that's called the combined gas law equation. Now, let's say that temperature was this constant. So this temperature equals this temperature. Okay? If I said to you, xy over 2 equals x squared y squared over 2, what could you do to that from algebra right away? What could you do? What is it?
Multiply by 2 and inside.
Yeah, multiple by 2 and cancel it. And you're left with x squared, sorry, you're left with
xy equals x squared.
xy equals x squared y squared, aren't you? Yes or no? Aren't you? So what you're left with, if T1 and T2 are equal, can't you cross them out?
Yes.
And you're left with this? Right? Yes? Boyle's law. Right? If V1 equaled V2, if volume were constant, wouldn't the volume cancel? And what are you left with?
Pressure over.
Yeah, pressure over temperature, right? So you're left with P1 T1 equals P2 T2, and volume is constant, and that's going to be Gay-Lussac. Gay-Lussac's law, yeah? Yeah, now I'm going to say that P is constant. P is constant. You're left with V over T equals V over T, and P is constant, and that's going to be Charles's law. Easy? Yes or no? Yes? So let's do a combined gas law problem. Okay? I'm going to do a combined gas law problem right now. All right. Write down in your notebook, write down the following. This is the way I do. This is the way I do. Mr. Darcy, who's been doing this his entire adult life, still does gas law problems. Okay? I write down the equation. I write down a list. Okay? That's what I write all the time. Before I do a combined gas law problem, I do that. And now I'm going to read the problem to you. You ready? Yes? The volume of a gas-filled balloon is 30 liters at 313 K. Okay? 30 liters at 313 K. So it's going to be 30 liters at 313 Kelvin. Correct? There's a gas. And a pressure of 153 kPa. 153 kPa. Right? Those are the initial conditions. Whatever's given first, we're going to call initial. Yes? And then it says, what would be the volume at STP? What's the volume? What's STP?
Standard temperature.
And what's the standard temperature?
273 Kelvin.
And the pressure?
101.3 kilopascal.
101.3 kilopascals.
1 atmosphere.
Right?
Yeah.
Is that right? You get it?
Yeah.
Should I rewrite kilopascals? Okay. You get it? Now, plug in. We have the units okay. Kilopascal, liters, Kelvin, Pascal. So we're going to calculate it in liters, and that's okay. And then temperature. Everything's cool, right? So I can just put in numbers. just looks easier when you calculate it. Is that okay? Yusef, is that okay? Excellent. So we're going to say 153 up here. I'm going to say 30. I'm going to say temperature is 313. And I'm going to say what? I'm going to say P2 is 101.3. V2 is what I'm calculating. And 273. Okay. So in your calculator, this is what I do. Okay? This is what I do. Are you ready? Want me to give you an easy way of doing it? This is what I do. I don't use parentheses. This is exactly what I do every time, and it's always right. You ready? 153 times 30 times 273. Yes? Hit divided by 313. Divided by 313. Hit divided by again. Hit divided by again. 101.3.
39.2.
Is that what you get? 39.2?
0.5.
39.5? V2 equals 39.5 liters. What did I end up doing? Yes?
X, what's it called? I can't remember. I don't know what it's called in English.
Cross multiply and divide. Yes. How do you say it in Arabic?
It's in French, I don't know.
How do you say it in French?
Factorisation de X.
Oh my God, it sounds like you need medical attention.
Factorization of X, basically.
Excellent.
Factorization is
So what I did was I said 153 times 30, this times this, 273, divided by the rest, cross multiply and divide. This was equal 101.3, 313, V2. Is that on the screen? Barely. I'm going to move this a little bit. Okay. And then what I did was I said, okay. I said, I'm going to divide by this. 101.3, 313. And then I'm going to get rid of this. And this is V2. And that equals this. Clear? You get it? All right. We are off. Clear? Okay.
So I have a question.